Hello, friends. Welcome to Science Talk. I'm your host, Jim Massa. So, I want to share with you this article that appeared in EOS, which is sort of like a headline publication of the AGU. And came out 1st of February. More fires, more problems. The increasing incidence of wildfire in the Arctic is not only thawing the permafrost, but also changing the entire underlying structure of the region. And you can see who the author there is Danielle Borteau. And here's a photo showing polygons. Polygon patterns appear in a thermal karst landscape caused by thawing permafrost in the ice-rich northern Alaskan tundra, called the North Slope. Pretty flat up there. The Anaktuvik River fire. Anaktuvik is on the north side of the Brooks Range. It's only accessible by plane. In the summertime, you can go snow machining around there in the wintertime, but there's no roads where you can drive to it. Anaktuvik is also what's called the Gates of the Arctic. There's a national park there. It's called Gates of the Arctic, and it's an incredible place to visit and see. There's a native village there, and subsistence lifestyle. It's a spectacularly gorgeous place. So they had a fire in 2007. It burned through 100,000 hectares in about 3 months of continuous burning, basically until the snow flew. This fire not only changed the area vegetation, it thawed the permafrost, led to formation of a thermal karst, and this probably is indicative of what's to come. And by the way, you have a lot of what's called ghost fires, like the fires appear to stop burning, and you get your snow layers and this, that, and the other thing, but they still continue to smolder. And then oftentimes, when all the melting, come springtime happens, air temperature warmed up, the ground dries a little bit, these fires can just reactivate. Arctic permafrost stores 33, that's 1/3 of Earth's organic carbon, even though it covers only 20% of the planet. It also acts as the structural foundation, physically, ecologically, for the entire Pan-Arctic region. Permafrost thawing has cascading effects on the hydrological conditions of the landscape and ice and triggers changes in vegetation, releases stored carbon. Right, we discussed this countless times before. Basically, you thaw out the permafrost, you release methane. Methane is a greenhouse gas. The warming increases the melt and thaw rate, right? So you thaw out more permafrost, releasing more methane, etc., etc. And that's it. Almost everything hinges on permafrost in the Arctic ecosystem, said Yaping Chen, who is a postdoctoral research associate at the College of William and Mary's Virginia Institute of Marine Science. We just usually call it VIMS for short. So trying to figure out, what was the impacts of these fires. They are increasing. How this affects climate change. How climate change might increase the amount of thermal karst. Right? Thermal karst, uneven landform that the permafrost thaws, not melts, unless there's ice. Ice melts, the ground thaws. Thermal karst is the result of the degradation of permafrost and provides reduced carbon sequestration and fewer niche ecosystems than does permafrost. So Chen says we have poor knowledge about the presence of permafrost. We don't know exactly where it is or how much there is of it. Well, we have a good idea. I mean, that's not quite a correct statement. I mean, we know the extent of it. We know how deep it goes. Now, if you're talking about precise volumes and precise amounts, okay, yes, we need to increase that information. We need to get that data. Lots of estimates, but we can rest assured we know it's in the tens, if not hundreds, of gigatons. In the longest temporal study done yet, Chen and her colleagues analyzed 7 decades of extremely high-resolution imagery to better understand how fires and climate change stimulate thermal karst formation. They focused on the Noatak National Preserve in Alaska, which is kind of northwest. It's around the Kotzebue area up that way. It's getting warm. It's warm and it's getting warmer. Already 2.1 degrees C warmer than it was in 1950. And it had the most fires during the period studied. And overall, they found that between 1950 and 2015, that's 65 years, the incidence of thermal karst formation increased by 60% due to the combination of wildfires, climate change. And they published their findings in One Earth. The major result is that although fire only burned about 3% of the Arctic landscape, it is responsible for more than 10% of thermal karst formation. In other words, there has to be something else explaining the formation of thermal karst. And that basically comes down to climate change. Not just fires, but a warming atmosphere, a warming planet, a warming ground. Researchers also found that fires increase thermal karst formation for up to 80 years post-fire. In other words, even after the fire ends, the effects are felt for that long. She goes on to state, normally people didn't think fire is an important factor because it doesn't occur often in tundra ecosystems, but our finding supported that fire is actually very important. In boreal forests, such a formation lasts approximately 2 to 3 decades. Once thermal karst releases ancient carbon from the soil may never recover. And with predicted increases on Arctic fires, these effects will become more consequential. Now, I just want to make a distinction here. They're focusing basically on tundra. We know about the boreal forest. That's a different ecosystem than the tundra. And we've seen, Sweden, Alaska, Siberia. We've seen how extensive and dramatic those fires have been. They're talking about the tundra. And yeah, the tundra doesn't really catch on fire, but here it is, it's happening. Apart from releasing carbon into the atmosphere, the disappearance of permafrost also threatens infrastructure and communities that are built on it. And I discussed that issue with you before. So, Antony Lukowitz said that this study is a significant piece of work. Antony Lukowitz is a professor of geography, environment, and geomatics at the University of Ottawa, not involved in the study. Climate change is really doing the work here. Summer air temperatures are the driver of this thermal karst change, and hot summers, which were very rare in the past, are becoming more and more common. It's those extreme hot summers that are really making the difference. Okay, so now what about what happens to the ground? How is that changing? Undisturbed permafrost is covered by an insulating layer of vegetation organic matter, which protects it from climate change. But when there's a fire, this protection is burned away and the permafrost is now exposed to the warming temperatures where it will thaw out, and then microbes act on the organic carbon and methane is released. And this is when it begins to collapse into thermal karst. Fires also deposit a layer of charcoal, and you see where that's going, right? That basically does what? It changes the ground's albedo. In other words, reduces the albedo so there's less reflection of energy back into space. It starts absorbing more energy than the surrounding unburned area. And that, of course, increases the ground right there. This is another positive feedback that causes permafrost to thaw. However, repeat burning does not necessarily result in more thermal karst. That's because the first fire changes the soil. Permafrost thaw, unsurprisingly, makes the ground wetter and therefore less easy to burn. But the first fire also supports the growth of more burn-resistant species as tundra vegetation. These species store less carbon than traditional tundra plants, such as mosses and shrubs. Mosses need a very damp, moist ground and area to thrive. Over time, the entire landscape may drain and export carbon and fresh water into the Arctic Ocean or nearby rivers. This water may also release methane. When the landscape drains, it actually makes the ground drier and creates a positive impact on future fire to occur or for future fire to occur. So, next step is they want to investigate the larger impact of this permafrost change on the wider ecosystem, basically trying to quantify how much carbon was released, how the hydrological regimes in different areas have changed, and they plan on testing the findings in other Arctic areas, including Siberia, where wildfires in 2021 burned almost 20 million hectares. Well, keep in mind that was in a boreal forest. But still, if they're talking about you finding methods to estimate how much carbon was released, sure, you can apply that to areas of boreal forest where there was fires. So Dr. Chen continues, in the future, we definitely expect to see more rapid, more expansive permafrost thaw. We are creating larger consequences for the global climate ecosystem, all of which contributes to the overall warming that we're seeing, that contributes to ever more positive feedback loops, ever more exponentiation, which then only increases the temperature increase projections. So, this study is very, basically is telling us what was suspected. It was able to quantify that fires cause the ground to release more carbon. And therefore, you dry out the ground and then you set up a positive feedback loop. Yet another of how many feedback loops have we discussed throughout these videos I have made. It's significant. You got the methane in the terrestrial permafrost. You got the methane in the aquatic permafrost, such as what's found in the Arctic Ocean shelf system, which is also being released. So we're increasing considerably the amount of methane that's getting into the atmosphere, and I'm not going to belabor the point. We all know what that means.
Just a quick update. Massive wildfires taking place in Siberia, releasing more methane and CO2. And of course, even though it's in a boreal forest, you still have the issues we discussed in this video, mainly decreased albedo, charcoal-like depositions, all with the changing condition of the ground that will be felt for decades to come. Typically, the Russian military deals with fires, but they are engaged elsewhere, which is making this rage more out of control with ever more harmful effects. Thank you for your time.
Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.